So hello my dear students, today we are going to talk about a new concept, that is annihilating polynomial of a matrix. The concept is very simple and it is very interesting as well. So over here a polynomial f of lambda is said to annihilate a matrix A if f of A is equal to 0. So what is the meaning of this? So meaning is simple. Now we have seen the characteristic polynomial. We have also seen the Cayley-Hamilton theorem. So what does the Cayley-Hamilton theorem say? Every square matrix satisfies its own characteristic equation. So we have already come across the concept of annihilating polynomial in case of what? The Cayley-Hamilton theorem. So what is actually happening there? So whenever we think of a characteristic polynomial, it is given by determinant of xi minus a. So by Cayley-Hamilton theorem, the matrix is satisfying this polynomial, means we are having f of a is equal to 0. So the meaning is that the characteristic polynomial is annihilating the matrix A. Are you getting my point? That is what is happening. Because if you are having a certain matrix A, suppose, and suppose your characteristic polynomial is x cube plus x square plus minus x plus 1, let me say. So by Cayley-Hamilton theorem, what is going to happen? Now since this is your characteristic polynomial, so by Cayley-Hamilton theorem you will have a cube plus a square minus a plus I is equal to 0, and that is nothing but what? That is nothing but f of a is equal to 0. It means that this polynomial is annihilating the matrix A. Annihilating in the sense it is killing the matrix A, because if you put x is equal to A on the right hand side, what you are getting? 0. Okay, I hope you got the meaning of annihilating polynomial. So that is the best example, that characteristic polynomial is annihilating a matrix A. So I will say here example characteristic polynomial. I will say characteristic polynomial f of x is equal to determinant of xi minus a annihilates. And if you want to take another example, so if you have some matrix B, suppose, and if you are having some polynomial f of x is equal to, let me say, some x square plus 1, and if this is satisfied, and let me say f of a is equal f of b now, isn't it? And suppose this is happening, f of b is equal to b square plus I is equal to 0, then what we will say? This f of x, so you can say that is we can say, I will say, when we say b f of x annihilates what? B, isn't it? Okay, so I hope you are getting the point of the annihilating polynomial. Now next is the definition of monic polynomial, which we have already seen. So polynomial is said to be monic if its leading coefficient is 1. So a characteristic polynomial is an example of monic polynomial, or you can take any example of your choice. For example, if I are having x to the power 5 plus 6 x raised to 6 plus x raised to 4 plus x cube plus 1, is it a monic polynomial? The answer is no, it is not monic, because the degree of the polynomial is 6, isn't it? Because x raised to 6 is present and its coefficient is 1. So what do you mean by monic polynomial? The coefficient of the degree term should be 1. Okay, so if I take x to the power 7 plus 5x raised to 6 plus x to the power 3 plus 2x square plus 9, now in this case it is going to be monic, because degree of the polynomial is 7, and you can see the coefficient of x raised to 7 is 1.